Thanks very much for your time, Dave. David Anderson is our expert in building automation controls. He is working very actively with the ASHRAE committee that is developing this particular standard. So I let Dave bring an update and a very short update here, and then uh, tell me if you want me to cut back and forth here, Dave, between Basecamp and this draft here. And I'd be happy to see you're already seeing me get lost in all my, here we go, get lost in all of my tabs. So go ahead, Dave.
Yeah, no, go ahead back to that other window you just had that showed the list of the different 36P events. It was well, the other one.
36P events.
You had another page up there, that page.
But I'm not.
Okay, so there's the schedule of the public review periods. Those are the existing ones. 36P, it's pretty small on my screen here, so I can't really read that as well.
I'm going to expand it,
like,
but it's actually not posted.
Just do a Control Plus and see. There you go.
But am I seeing it on this list? I'm not.
No. Okay. I just wanted to see if there's anything on there scheduled.
So here's Basecamp.
Okay.
And Basecamp is, for this particular project, this is one of the most active. And I will tell you, as somebody who looks across many standard suites, this is one of the better ones that are run. This is one of the better ones to run. I believe where you're at with this, and I did talk to Mark by email, that you're all bundled up and ready to take this under your arms to the ASHRAE meetings. Will you be there next month, Dave?
No.
Okay. Will anybody from U of M be there?
That I don't know.
Okay. Well, we're a pretty big stakeholder here. I know you were there before. I know we were there before. We may well have to punt. It's I'm trying to remember where it's at. Is it in Tennessee? Where is it going to be this year? We'll have to find out where it's at.
Yeah, I only usually see the ones or pay attention to the ones for the semi-annual ones, but there are a lot more meetings than that.
Yeah.
So I'm not sure where that next one is.
Yeah, okay. Well, we'll have to figure out where that's at. It's soon, best I understand. I believe it is soon. And we will make some arrangements because we do need to tool up for, here we are. It starts the 25th and it runs until the 29th. Okay. So it's in, it'll be in St. Louis. Okay. All right, so this is the boots on the ground, one of several. So we'll have to talk to some of the other committee members there. But if you want to just give a briefing, and from the standpoint of, my primary concern is that we not overbuild or do something too different from what we already have in our building automation control systems. We're probably in fairly good shape there, and where we are in this is it's a very long document, and it gets into more detail than most of the regulatory talent in the United States that they can deal with. But of course, you have this divergence between technical talent not being so inclined to politics. You certainly don't have politicians very interested in technical details, and so that's the space where we try to live. We try to stitch those two, try to hold one side with one hand and the other side with the other hand to try to bridge the two. So, if you could for a moment, just give us tell us where you're at with this and where you think how this document will help deliver value to the industry.
Well, I do think that it's getting close to final review, and the input that we've been able to have along the way has been valuable. We've had some success in, you can see even in the older version, the CO2 sensors for each room. It's just where applicable rather than a mandatory you have to put one in every room. So we can, specify whether or not we think it's important to have that in a particular room, and so only include them where there really is true value to having them rather than having them everywhere regardless of the extra cost involved. So that's a good thing. And we also have, we've had some input about things like the freeze protection. When they went to define the sequences for how fan systems control and how fast they respond and whether or not they're responding too fast so that they might overshoot. Well, some of those could cause a problem with us being able to control something fast when we really need to in order to prevent a freeze trip of the fan system. So there we were able to make sure that gets written in properly, so there are times where you do need to respond faster than what the limitations were that were some of the limitations proposed. So that's just a general, being able to see from various points of view how the control sequences would affect you. So somebody down in the southern states would certainly have different requirements and concerns than we do up in the northern locations. So part of that whole process, it is important to have different people from around the country so they can get their particular scenarios considered in these sequences. So, and I think they've done a good job of doing that.
Well, you mentioned the CO2 sensors. We seem to meet that prescriptive requirement, or let's put it this way, a proposal from a number of interest groups, namely the manufacturers, of course, and we've been able to push back on that. We saw that I believe in 189, they were trying to sock that one in there, so we managed to get them back. And you say here on 36P that you're a little bit more, less prescriptive and more, we'll say, performance. Not one that's a one-size-fits-all, which has the practical effect of increasing the revenue stream of manufacturers, to one that's a little bit more tailored to the purpose by designers. That's a large economic issue. And I'm going to guess that a CO2 sensor in every room, and that's where they wanted to have it nearly in 189, if you recall. What are we looking at there? It's not just the CO2 sensor, it's the wiring it and bringing it back to the building automation system, right? You've got to take it to your first terminal. Then, of course, you've got programming and all that and maintenance. Any given, let's say a CO2 sensor down in the basement of one of the classrooms at the MLB building, the ones with no windows. What is a CO2 sensor mounted per code in a drop ceiling? What do you think the effective cost of that the first time around is?
Well, a lot depends on, of course, the type of sensor used and what the cost of that sensor is. But between the sensor and the cost of getting it connected back to the building automation system, you could have $2,000 a point. And if you have 600 rooms, you're talking about $1.2 million basically for one building as an impact. So this is substantial impact if we had to put them in every room.
Yeah, and I always ask the question, the requirement seems to be so, to some people it's not ridiculous, but to us it does seem ridiculous.
Part of that is we find that the actual, people being in the space that would be generating the CO2 also drive up the air requirements for just keeping the room at a particular temperature, so the box is open anyway and fresh air comes into the space. So in most cases, the CO2 sensor isn't needed to determine whether or not we need air in the space. It's driven by the temperature from the occupants. So that's what we find is there are very few cases where we have enough, some of them auditoriums and so forth, you can get enough people coming in quickly enough that raises the CO2 level to where it actually makes sense to put them in. So it's really a case-by-case basis rather than a let's put them in everywhere.
Yeah. Yeah, how do I approach a manufacturer's general interest to sell more of his CO2 sensors? How do I because we need the manufacturer's innovation, but it just strikes me as such a clear case of what I'll call green overreach or market making on their behalf. That I'm in this video conference here, I'll just open the door to any manufacturer who wants to have a similar discussion with us about why we have to have carbon dioxide sensors in every room, in every campus, in every building in the United States of America. It just strikes us as overreach, and they should know better. So that much said, can we move on to freeze protection on this one, Dave? Because I don't know, that's an area that I'm not as familiar with. Tell us a little bit about how the freeze protection. Now, first of all, I'm going to remind our listeners that this is the kind of thinking that's went in before we see the first draft. So ASHRAE will ultimately be posting 36P here on their public review site. But ahead of that, they're going to vet and probably do all the things they want to do at a meeting. They want to make sure it goes out to the public and doesn't get hammered upon. So they're doing all the right things. Of course, remember that ASHRAE moves very fast. We may have only 30 days to comment. Here's an example of a 30-day review period. They certainly have, among experts, given it a fair hearing. In my experience, this document among experts has been given a fair hearing with people like you. So I did want to put that out there. So could you talk a little bit about the freeze protection, David? I'm not as familiar with that. I'm eager to learn.
Okay. Well, one of the issues that was brought up was that there can be problems with oscillations or over eager controls trying to make adjustments and end up causing upsets of others, further downstream. And so an attempt was made in, the whole let's determine an optimum sequence of operation or way of controlling a fan system for the most energy efficient method of operation that we can come up with, given the current state of technology and so forth. And so they were trying to make a rate of change limit to say, you can't move the control more than so much of its range per second or per minute, and so that kind of a limitation may be good in keeping something from overshooting or keeping it from oscillating and so forth, but when it comes to something like, you have outside air dampers and a fan system being off in the morning when you first start it up, the fan plenum is warm and you're in a northern climate, well, it has a set point of, say, 55 degrees. It's going to try to open the outside air dampers to get the temperature down to 55 degrees. Well, it's sitting there at 75 or whatever the plenum's resting at, and so it opens these dampers pretty. As it opens them up, cold air rushes in. Well, that temperature starts dropping pretty rapidly, and you need to be able to respond to that, and you need to be able to shut those dampers quickly enough to not let it get below a temperature that is designed to protect the coils against freezing. So the freeze protection, there's a freeze stat device that will trip if and has a certain setting. It might be 40 degrees or whatever, but if it senses that temperature gets down to that point, it's going to, as a safety measure, it's going to shut the fan down to prevent the coils from freezing. So we want to make sure that that control is responsive enough to be able to rapidly adjust those mixed air dampers to prevent the unit from tripping out on a freeze stat and shutting down, and someone has to physically go out and reset the freeze stat to get the fan running again. And so for the northern climates and the further north, or if you're up in the northern Minnesota area, it's probably a lot worse than it is in Michigan, but it's also pretty bad here in Michigan. And we routinely see things that trip out on freeze stat if they're not controlled just right. So we wanted to make sure that some of the control limitations didn't preclude the ability to actually control your fan in a way that keeps it from tripping out on freeze stat, as one example.
That sounds very.
That's basically all that was.
It sounds rather similar to. Well, thank you for that. In the back of my mind, I'm listening to you, and I'm thinking about what we would do in engineering, in both mechanical and electrical, about hunting. Hunting is kind of a natural phenomena in which a system hunts for equilibrium, about a balance point. Maybe it's not quite the same concept, but I can see so isn't that.
Yeah, I think that is the same concept. Yes, they do try to prevent it from hunting, and that's part of the let's let the rate of change be something that can be something that's reasonable that would prevent some of that hunting. Well, in this case, you can still have those limits, but you need to be able to have the override that says, wait a minute, our rate of change in this case is so extreme, we've got to react much quicker than you would normally because it would potentially shut the unit down.
Yeah. So. Okay. Well, all right. That's we're coming on to our time limit. There's always more to talk about. I would. Is there a problem with you? Do you have other obligations that prohibit you from going to the ASHRAE conference, Dave? Or is it just a matter of travel funding?
That's a good question, and I'd have to check the calendar. I think it's probably more a matter of the time and the cost involved in traveling.
Okay, all right. Well, we'll have to talk offline about some of that, but this is just a fair update. We should be expecting this one. Dave's been active on this for nearly 2 years now, best I know, and so he's one of the first people I go to. He's probably run one of the largest BAS systems in the country, so he's a respected voice. Again, I just want to restate why I'm raising this issue of building automation controls. Because we're finding regulators and legislators are becoming excited about the Internet of Things, and we actually already have an Internet of Things on college campuses and have for many years. It's less at the consumer level, however, and we are active in some of the standards of the Consumer Technology Association. I'm not sure, Dave, if you're familiar with these, but these are the standards that determine how a utility communicates with a water heater. So you can see this happening at the consumer level. But of course, these trade associations will be approaching the legislators, and the legislators see lots of opportunities for meetings and bloviating about policy and such and so forth. Meanwhile, we got bills to pay here, and we want to see some pattern or some outlook. We like to estimate our outlook for short, intermediate, and long-term gain from participating in all this, in order to make sure we don't pay too much. So that's I guess that's all we have time for, Dave. I'm very grateful for your time. I'll put this up on our web page, and I guess I will I'll close by wishing you a good weekend, and thanks for your time. We'll see you next week.
Sure. Thank you.
Bye-bye.